In this video, we will work out some basic optimization problems. Find two positive numbers that satisfy the given requirements. Number 4, the product is 185 and the sum is a minimum. For starters, let's define our variables. Let's let x equal one of the numbers and we will let y equal the other. Also, they gave us this secondary equation. The product is 185. So using x and y, that means x times y must equal 185. We are told that the sum is a minimum. So we need to minimize the sum. I'm going to go ahead and define a new variable. We will let s equal x plus y. So s is the sum that we are trying to minimize. Right now this sum has two variables to it. I'd like to get this down to a single variable, so I need to replace one of these. Let's take this secondary equation and solve it for y. So dividing both sides by x, we get y equals 185 over x. We can now take this and substitute for y. So this is my new expression for the sum. I'm going to rewrite this a tiny bit by bringing the x out of the denominator. So I will have x plus 185 x to the negative 1 power. We know that the minimum of a function will occur when the derivative is equal to 0. So let's find the derivative of the sum. The derivative of x is 1, and for this part I'm going to use the power rule. So this negative 1 times 185 is negative 185. Reduce this power by 1, so I have negative 2 power. This is the derivative. This would be the same as s prime is equal to 1 minus 185 over x squared. A moment ago I said that the minimum would always occur when the derivative was equal to 0. It will sometimes occur when the derivative is undefined, so we need to check both of these. Let's start with setting the derivative equal to 0. So I will have 1 minus 185 over x squared is equal to 0. Adding this fraction to both sides, I get 1 is equal to 185 over x squared. Multiplying both sides by x squared, I get x squared is equal to 185. Taking the square root of both sides, I get x is equal to plus or minus the square root of 85. But the directions say find two positive numbers. So we will disregard the negative and just say x is positive square root of 85. So this is one candidate for x. Let's see if we can find another candidate by considering what value of x will cause s prime to be undefined. We see this denominator, so if x were 0, that would cause s prime to be undefined. So what about x is 0? Is this another candidate? Well, no, because y equals 185 divided by x, and you cannot divide by 0. Or if I look at this level, the product has to be 185. If x is allowed to be 0, then we won't get 185. So there are no values other than 0 that will cause the derivative to be undefined, so we can forget about this. That means x equals square root of 85 is the value that we're looking for. So we have x. Let's find the y value now. Y is equal to 185 divided by x. So that means that y is equal to 185 divided by the square root of 185. So we could leave it like this, but if you rationalize the denominator, which is just so easy that I kind of want to do it, then I end up with y equals 185 radical 185 over 185. So of course these 185s cancel each other out, and I end up with y equals radical 185. So these are the values that will minimize the sum. But for an AP Calculus class, you should always write your answers in a complete sentence. The two numbers that minimize the sum are radical 185 and radical 185. For number 6, they are giving us the secondary equation that the second number is the reciprocal of the first number. So that would mean, for example, that y is equal to 1 over x. We are again being asked to minimize the sum. But let's make the substitution so we can get one variable instead of two. So we can write the sum as x plus 1 over x. Later I need to take the derivative, so it will be easier if I write it as x plus x to the negative 1 power. The minimum will occur when the derivative is either equal to 0 or undefined. So let's find the derivative. The derivative of x is 1, and now I'm using the power rule. The negative 1 comes to the front. I reduce the exponent by 1. This could be written as s prime is equal to 1 minus 1 over x squared. The minimum will occur when s prime is equal to 0 or when s prime is undefined. Let's start by setting s prime equal to 0. So I would have 1 minus 1 over x squared is equal to 0. Adding this fraction to both sides, I get 1 is equal to 1 over x squared. Multiplying both sides by x squared, I get x squared is equal to 1. Taking the square root of both sides, I get x is equal to 1. I'm not going to say plus or minus 1 because in the directions we are told that we need two positive numbers. Now what about when s prime is undefined? I see this x squared is in the denominator, so this would be undefined if x were equal to 0. But looking back at y equals 1 over x, we see that x cannot equal 0. That would make y be undefined. So that means x equals 1 has to be the answer. Let's go ahead and plug this x back in so we can find what y is. So y will equal 1 over 1, which of course means that y is equal to 1. So these are the two numbers. Let's write it as a sentence. The two numbers that minimize the sum are 1 and 1. For problem number 8, they give us the secondary equation. The sum of the first number squared and the second number is 54. So the sum of the first number squared and the second number is 54. So this is the secondary equation. Now here comes the equation that we are supposed to maximize this time. The product is a maximum. So that means that x times y. Well, let me write p equals x times y, p for product. We have two variables. I'd like to have only one variable. So I'm going to isolate the y. Subtracting x squared from both sides, I have y equals 54 minus x squared. So I can now substitute that in right here. So my product can be x times 54 minus x squared. I think I'll go ahead and distribute the x so I don't need to do the product rule. So this will be 54x minus x cubed. We know that the maximum will happen when the derivative is either equal to 0 or is undefined. So let's find the derivative. P prime will equal, the derivative of 54x is 54. And using the power rule, I have negative 3x squared. So this is the derivative. Normally I say that the maximum will occur when the derivative is equal to 0 or if the derivative is undefined. But a polynomial is defined everywhere, so we don't need to worry about where the derivative is undefined. So let's just set the derivative equal to 0. So we have 54 minus 3x squared is equal to 0. Adding 3x squared to both sides, we have 54 is equal to 3x squared. Dividing both sides by 3, we have 18 is equal to x squared. Taking the square root of both sides and sort of flipping this around, I get x is equal to the square root of 18. I'm not saying plus or minus because the direction said only positive numbers allowed. So x equals 18 is the value of x that will maximize the product. It's the only one that we have. Let's just go ahead and find the y value that goes with it. So y equals 54 minus the square root of 18 squared. So that means y is equal to 54 minus 18. So y equals 36. And these are the two numbers that will maximize the product. Let's write this up as a sentence. The two numbers that maximize the product are radical 18 and 36. Number 9, find the length and width of a rectangle that has a perimeter of 80 meters and a maximum area. So here's my rectangle with sides x and y, which of course means that we will have a y here and an x here. The perimeter is the sum of all the sides, so that'll be 2x plus 2y. So that's the perimeter, and we are given the secondary equation that the perimeter is 80 meters. So this should equal 80. What are we trying to maximize? We are to maximize the area. And the area of a rectangle is the length times width. So this will be, well, let me write area equals x times y. This has two variables. I'd really like only one variable. So let's isolate y over here. First of all, dividing both sides by 2, I'm going to get x plus y is equal to 40. Now subtracting x from both sides, I have y equals 40 minus x. So let's substitute that right here, and we will get a new expression for area that only has one variable, x times 40 minus x. Let's go ahead and distribute to make it easier to take the derivative later, and I have 40x minus x squared. The maximum area will occur when the derivative is either equal to 0 or is undefined. So let's find that derivative. A prime. The derivative of 40x is 40, and the derivative of negative x squared, we're doing the power rule, so the 2 comes in the front, and we have negative 2x. A polynomial such as this is defined everywhere, so we don't need to worry about where the derivative is undefined. We only have to set the derivative equal to 0 to find the maximum area. So 40 minus 2x is equal to 0. Adding 2x to both sides, that's 40 equals 2x. Dividing both sides by 2, that's x is equal to 20. So this is one dimension of the rectangle. Let's go ahead and find the other dimension by substituting this back in right here. So y will equal 40 minus 20. So y will also equal 20. So these are the dimensions of the rectangle. I guess we could be more specific and call it a square, which maximize the area. Let's write this up as a complete sentence. The side lengths of the rectangle which maximize area are 20 and 20. Wait a minute, they gave us units this time, 80 meters. So I need to include that in my answer. For full credit, always remember to include your units. Number 10 is a little more abstract. No numbers. Find the length and width of a rectangle that has a perimeter of p meters and a maximum area. So we know that the perimeter equals 2x plus 2y, where x and y are the sides of the rectangle. We saw this in problem number 9. We will treat p as a constant. We need to maximize the area, and the area of a rectangle is the product of the dimensions. So the area will be x times y. This is too many variables, so I want to do the same thing I did in problem number 9, and I want to get y by itself. So subtracting 2x from both sides, I have p minus 2x is equal to 2y. Dividing both sides by 2, we get p over 2 minus x equals y. It's time to substitute this expression for y over here. So I now have the area is equal to x times p over 2 minus x. Let's go ahead and distribute the x. So we get a is equal to p over 2x minus x squared. Remember, we're treating p as a constant, which means that p over 2 is also a constant. The maximum area will occur when the derivative is equal to 0. So let's find the derivative. The derivative of p over 2x is p over 2. All right, it's just the constant. The derivative of negative x squared is negative 2x. Let's set the derivative equal to 0 to find the x value that maximizes the area. So we have p over 2 minus 2x is equal to 0. Adding 2x to both sides, we have p over 2 is equal to 2x. Now, dividing both sides by 2, remember when you divide a fraction by a number, you simply put that number in the denominator and multiply. So we end up with p over 4 is equal to x. So that's the x value that maximizes the area. But what about the y value? Let's substitute this in over here. So we get y equals p over 2 minus x. So that's minus p over 4. Let's make like denominators. So we have y equals 2p over 4 minus p over 4. So y equals p over 4. So these are the values of x and y that maximize the area. Let's write this up as a sentence. The side lengths of the rectangle that maximize the area are p over 4 meters and p over 4 meters. Don't forget your units. Number 11, find the length and width of a rectangle that has an area of 32 square feet and a minimum perimeter. Here is our secondary equation. The area is 32 square feet. So that means that x times y has to equal 32. We are being asked to minimize the perimeter. So the perimeter is 2x plus 2y. This is too many variables. So let's solve the secondary equation for y so we can substitute. Dividing both sides by x, we have y equals 32 over x. Let's go ahead and substitute that in. So we get perimeter is equal to 2x plus 2 times 32 over x. Let's simplify this a little bit. 2 times 32 is 64. I'm also going to bring the x out of the denominator and make it x to the negative 1 power. So we will have perimeter is equal to 2x plus 64 x to the negative 1 power. Since the minimum perimeter will occur when the derivative is either equal to 0 or undefined, we need to find the derivative. So p prime is equal to, the derivative of 2x is 2, and here comes the power rule. The negative 1 multiplies the 64, and we have negative 64. We decrease the exponent by 1, so we have negative 2. So p prime is 2 minus 64 over x squared. Normally, I always say that the minimum perimeter will occur when p prime is equal to 0 or when p prime is undefined. However, just at a glance, I see that p prime will be undefined when x is 0. But looking back here, x cannot equal 0. That would make y undefined. So we don't have to worry about where p prime is undefined. We just need to set p prime equal to 0. So let's set 2 minus 64 over x squared equal to 0. Adding 64 over x squared to both sides, we get 2 equals 64 over x squared. A nice shortcut is that we can always swap these, and we end up with x squared is equal to 64 divided by 2. So x squared is equal to 32. Taking the square root of both sides, x is equal to the square root of 32. We will not say plus or minus because x is a side length of a rectangle. You can't have a negative side length. So x is radical 32. What about y? Let's go ahead and substitute x equals the square root of 32 in right here. So that will give us y equals 32 over radical 32. If we rationalize by multiplying by radical 32 over radical 32, we get y equals 32 radical 32 over 32. And we notice that the 32's cancel each other out. So that leaves y equals radical 32. So these are the dimensions of the rectangle that minimize the perimeter. Radical 32 and radical 32. As always, for AP Calculus, you should write this as a complete sentence. The side lengths of the rectangle that minimize perimeter are radical 32 feet and radical 32 feet.